Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of generalizing transformations. This is standard 8.10a in the great state of Texas, and we are using item number 19 off the 2022 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So pentagon PQRST was graphed on a coordinate plane. So you know what? Let's visualize this here. So let's just make ourselves a coordinate plane. And I'm going to make a pentagon. I'm going to make it look kind of like a house or home base. Whatever you want to call it. All right, so there's my pentagon. PQRST. It's rotated 90 degrees counterclockwise about the origin to form PQRST prime. All right, so if I am going to rotate, I'm going to do a turn. It's going to kind of go this way. So I'm not just going to slide it over. That means it's going to point in a different direction as well. So it's going to look probably, without necessarily plotting it, something kind of like this. I'm trying to draw the same pentagon, but I know it's pointing in a different direction. Okay, and then it's counterclockwise, right? So the clock moves around to the right. This is going down to the left. All right, so here we go. We've got our new PQRST prime, and that's just the original PQRST. I'm not going to take the time to label the actual vertices here. So let's see which statement is true. All right. So the area of pentagon prime is not equal. Not equal to the area of PQRST. Well, it would be not equal if I had some type of dilation. So remember, when we use a dilation, what we'll do is we'll do like xy, and then it transforms using like 7x, 7y, right? Something like that. You make it 7 times bigger or 7 times smaller if you want to divide by 7. That would change the area. But we didn't do anything like that. We literally just tipped it over on its side, and it's just rotated counterclockwise. So this not makes this false. The areas are equal because I didn't dilate it. All right. So pentagon PQRST prime is not, again, congruent to pentagon PQRST. Once again, if I were to dilate this, then that would be correct. But if I do a rotation, which is what I did, if I do a reflection, I flip it across the y-axis or the x-axis, even if I do a translation, which is just a slide, right? 7 units up, 7 units to the left. All of those keep it congruent. These are all congruent because I'm not changing the shape or the size. I'm just moving it. So B is incorrect because it says it's not congruent. It still is congruent. The perimeter of PQRST prime is greater than. Okay, is greater than. Once again, it's like the same. They're telling me the same wrong answer 3 different ways. This was a simple rotation. I didn't dilate it, which means it didn't get any bigger, which means it didn't get any smaller, which means the perimeters are equal because it's the exact same shape. I just tipped it over on its side. I didn't make it any larger, didn't make it any smaller. So none of those are true. All that happens when you get a dilation. D, the angle measures of PQRST are congruent. There we go, congruent. Congruent means equal or the same. And yeah, it's the exact same shape, it's the exact same size, which means it's also the exact same angle measures because they didn't change the size. If you dilate it, you still get the same angle measures. It's the side lengths that change. So the angle measures don't even change when you dilate it. So our answer is D.